everyone, welcome to a new video. Harsh Verma this side, and just like the last day in which we are covering RIP, in this video we are going to cover EIGRP, Enhanced Interior Gateway Routing Protocol, from the same book, Network Warrior. For those who don't know, this is the book Network Warrior, and this book is specifically focused on the things that was missed during the CCNA preparation, particularly the practical side of things. And I am not covering this book throughout by chapter 1 to 10 or cover to cover, but actually noticing out or pointing out the things that is very critical to know. Okay, so without any further delay, let SSH into my phone and in which that I used to take notes and start the topic for the day. Those for the days or the only topic for the day is EIGRP, which stands for Enhanced Interior Gateway Routing Protocol. So Enhanced Interior Gateway Routing Protocol is a Cisco proprietary protocol which been opened or open standard in 2013 by Cisco, which means that the core features are still with the part of in the part of CCN, sorry, Cisco, but it can now be implemented in a multi-vendor setup with a limited feature set. Now, with limited feature set or in its default configuration, the EIGRP is very easy to set up, but it is not designed to scale. Not designed to scale means that if some organization contains plethora of devices, for example, the thousands of devices or etc., then in those scenarios, EIGRP may be much difficult to set up, and a manual and uh, throughout thoughtful changes is necessary in order to make EIGRP scale to large setup. EIGRP, as in name, is an interior gateway protocol, interior gateway routing protocol. So it even though the terminology used is autonomous system, it is referred to the EIGRP process or EIGRP process number, not of the autonomous system of an organization itself. Okay. Now, EIGRP contains a command that is no network and network IP address, which restricts the advertisement of the particular network range. So in the previous lecture, we have seen that we used a command passive interface and then interface name in RIP protocol to restrict the advertisement of a particular network range to that particular interface. We used to do that in order to because that interface may contain some endpoint devices, not a router. So advertisement on that interface will be wasteful of resource. That's why. So in order to, if we don't want to restrict some IP addresses in overall context, so we can restrict them using the same command. Then the next suggestion that is provided by the book is setting up wildcard mask at 0.0.0.0, which is equivalent to the prefix of /32 or 255, 255, 255, 255 is the preferred way of setting up route advertisement as it slims down the chances of surprise. So what this is saying that it is best way to advertise a particular route or a particular host address rather than its whole subnet. Because if we are advertising a whole subnet and in future some devices got removed or some devices got attached, uh, it may lead because even though the router is advertising its subnet, the device may not be present there. Okay, now if the broader matching is desired, if we have a compulsion to advertise the whole subnet, it is often better to use the broad mask combined with passive interface command to explicitly disable the routing on specific interface rather than relying on implicit matches that might change if the interfaces are added to the network. So as we say, as I just mentioned, that passive interface command is also an RIP command to restrict the advertisement to the particular interface. EIGRP also features the same thing. Okay, finally, no auto summary restricts the RIP like auto summary feature in EIGRP. So we have seen that EIGRP does possess very few common quirks with RIP. So it also used to auto summarize the messages. But if you recall correctly, the RIP version 1 does not even allow us to disable the auto summary, while RIP version 2 does. EIGRP also does offer to disable the auto summary. And finally, the last point of the day is EIGRP stores in information in three databases. First is the route database, the topology database, and the neighbor database. And we have written a thing which is what is a topology database? It contains the alternate possible route. Okay, so the route database is the final route. For example, the route in topology database, basically it will contain all the routes to the network. The route database is the final version that is going to be used, and it will be proposed to the routing table RIB, and there we finalize the route. And there is something called forwarding table in Cisco Express forwarding, if you have already seen too. I guess that I have taught that in video, which is a specifies version of RIP, routing information base, and that will contain the faster routes. So there is redundancy of information. And finally, the neighbor database consists of all the neighbors that are connected, directly connected, or with the router, or just like this. And this is for this video. Thank you for watching. Thank you for joining.